Our session starts. Now we are going to have a session about AI practices and data analytics. It will be chaired by Alper Bey, who is on the floor. Thank you. Thank you. It's very late. We agreed with Umut that we actually have drawn the shortest straw. But thank you for staying with us this late, for joining us as well. First of all, I would like to thank Turep for this event. It has been an event that I have made use of. I have learned a lot today, and it has been an efficient day for me. I hope that the session will be also efficient for all of us because we are joined by very distinguished guests. The title of this session is the digitalization and artificial intelligence for wind power plants. As you know, digitalization is one of the main topics. It has been a topical matter recently, along with artificial intelligence. The collection of data, the transfer of data, and the processing of data has been quite important, because it leads to digitalization. And when it comes to wind power plants, it is also important for the organization of the operators and their efficiency, and the digitalization of the whole process through which data can be turned into information. So those practices would be more practical. First of all, I will give the floor to our guests. I would like to kindly request them to introduce themselves first. Then we will continue with the speeches. We can start with you. Can you briefly introduce yourself? First of all, thank you for the kind invitation. My name is Mustafa Cangül. I am the chairman of the board at Drone Care. For a long time, we have been focused on drones as a solution. It is also a solution for storage, solar and wind power plants. And our goal is to make sure that these costly projects can become less costly and cost-effective and sustainable. That is what we are trying to do. And we think that we have offered very good solutions thus far, and in the future, I hope we will have much more successful projects. Thank you. Thank you for this kind invitation and for staying with us this late. My name is Murat Okyay. I am the founding partner and CEO of Kaoken. We have been in this business for the past 20 years. I studied in Houston. I started this job for oil and gas, and after I came back to Turkey, I was a consultant, and then I took interest in technology and data. Kaoken is a spin-off company, actually. We were focused on different sectors, but when we saw the opportunity in renewable energy and when we realized that the sector was lagging behind in terms of digitalization, we saw that there are lots of things to do. So as a Kaoken, we believe that the world needs more green energy. So without making investments, we have looked for ways to use data to make it more to make it more green, getting data from the fields to contribute to extra production or the reduction of revenue losses and optimization of maintenance plans to offer more revenue and value for investors. Thank you.
languages, and I'm sure this is something worth learning. My name is Saqib Saeed. I come from afar, from Pakistan. So for the first 20 years, I was under the water, working in the submarines. And that's where the only thing we do when we are under the water is to watch our sensors. And it's always the data coming out of them that tells us what's going on around us. And for the last 9 years, I've been doing pretty much the same, though not underwater this time, but inside wind farms. I literally live there and have been living on the wind farms for the 9 years. And we got a company called Algorithm Energy, and we branched out to Turkey. I'm very proud to introduce my partner, Turkish partner. He's a G man for the last 24 years, Mr. Tolga. And then we also branched out to Sweden, where we are doing pretty much the same thing under the name of Algorithm Energy. What we do is pretty much Mr. Bora does exactly, so I will skip on that. We do the same thing. We have the same approach with the data, and perhaps that would liven up the session. Well, you would be able to see those approaches at work. Thank you very much for the invite. I really thank you.
Güven Bey. Hello everyone. First of all, I would like to thank Turep for this event, and I would like to thank to you. It has been a very good event for us in terms of introducing what we do, promoting what we do, and gathering with people who share the same focus. It has been an efficient event. I am Güven Fidan. I am the founder of Alcazar. Since 2011, we have served as an advanced level engineering consultancy company. In 2019, we had a spin-off, shifting our focus on insurance, especially for renewable energy. You know, it started with a project. When we solved the problems, we collected weather data to see what we can do. Then we have identified problems to improve our products, and we try to provide benefits. We also organize OEM plans and we also offer services for insurance, energy investors, and financial institutions. And we would like them to exchange data. We have taken the first steps, so we continue to grow. Thank you. Before giving the floor to our speakers, I would like to note this. You know, when it comes to efficiency, people tend to think of consumption, usually. But when it comes to production, it also involves maximization and the prevention of losses and measures to be taken to start with. You know, it is something very important. So in this sense, efficiency is very important. So first of all, I will give the floor to Bora Bey and Saqib Bey because they do similar kinds of work. So how we can maximize production by using data. Then as a complementary piece, Can Bey will talk about other aspects. We can start with Bora if you want. I have a presentation, so can I have it on the screen? Okay, let's have Bora Bey's presentation on the screen. No, not this one. Let me gradually start. As I said before, we identified some problems, some gaps, and one of them is the amount of data generated. You know, an enormous amount of data is generated. You know, there was a saying that, you know, data is generated and we would look at it and not knowing what to do. This wasn't specific to Turkey. You know, usually this was the case. You know, data was generated and we didn't know what to do with it. But you can use data to create value. I usually ask this question. What do you think? how much data is generated in a year? How many gigabytes or terabytes? Do you have any idea? You can make up a number. It is nearly 70 terabytes. I checked the newest version of iPhone, Pro Max. It has a capacity to store 1 terabyte of data, so it can fill up an iPhone every 3 to 5 days without taking any pictures. So there is an enormous amount of data that you can use, and we have just started creating value out of this data. So in terms of maintenance, for the past 5 to 10 years, this sector is focused on collecting data. 10 years ago, this wasn't the case. When you had contracts with turbine manufacturers, you wouldn't even think about putting that into the contract. So it is now a must. In Europe or in the United States, maybe they are more advanced, but they collect data. Okay, we visualize data, but now it is time to take a step further. You need to couple it with artificial intelligence to create data. So that is what we are trying to focus on. I don't know if you can see here, but this is a work by Boston Consulting Group. I think it is very beneficial. I use it as a main reference, and they say that data can be used in different aspects of a project, ranging from the site identification to the maintenance and the commercialization. So now, if you use data, you can create additional data by 14 to 27%. You can see some stages here, but we are focused on is asset management. We have activated it. Then you also need to understand the opportunities are clustered in terms of operation and maintenance. So as Kaveh, that is what we rely on in terms of our expertise. One of the important points is to realize that artificial intelligence or data analytics is very complicated. There are many mathematical formulas which are very complicated. Even when I talk to data scientists in my team, sometimes I cannot understand what they mean. But the main thing is to make sure that the end users are the field officers, or those in the headquarters. So they are not data scientists. It should be simple. You can make it complicated, but for end users, it must be intelligible. So a lot of effort goes into that. So you need to make sure that it is reliable. The software is reliable. So it is not just about data science, but it's also presenting it in an intelligible way to the end user. That is what we are trying to do. We collect data, we run them through a different type of algorithm, and we are focused on 3 things. First one is to monitor whether each turbine performs in the best way possible. The blades might be rotating, but we should know that if it provides the best performance. Usually the focus is on being readily available. The second one is to reduce the losses. Turbines might stop as a part of a plan or without a plan. There might be some failures and breakdowns, so you need to estimate them beforehand. And the third one is the optimization of sales and operations. So we can look for ways to make estimations for production and to make plans for maintenance at the right time. Now, the first one, increasing revenue output. The main thing is the power curve here. And we always start with this question. Why should we work on this? Why should we make effort on this? Why should we invest in this? Or is it big enough to solve? We had a study. We worked on over 400 turbines across Turkey, and we concluded that 1 out of every 4 turbines had a significant underperformance. What I mean by underperformance is this, I can put it in a conservative way. It is underperformance by 7% or more. I'm not talking about 1% underperformance because it is not significant. So 1 out of 4, every 4 turbines has something wrong with it. So when is it realized? When is it noticed? Sometimes it takes 6 months or a year, a couple of years in some cases, to take notice of what is wrong with the turbine. So usually the main focus is the being readily available. So the analysis is not that easy. It requires advanced level data analytics. You need to sort them, and you also compare them with alert nodes, and you need to compare them with other sets of data. That is why we have identified the problem. We knew that it was a big problem, and we have made estimations. And to put it in a context, maybe I can give a few examples for you. Of course, on the screen you can see we are focused on the use of easiness. It is very intelligible. It can be used by anyone. It's a standard screen. There are a few things here. One of them with dots, you can see with dots the theoretical power curve. It is for manufacturers. And below you can see blue and orange dots and blue and orange lines, and you can also see dots. First of all, this is important. Of course, theoretical power curve is important. It is important to know about it, but it is not the right type of data to determine the performance of a turbine, because the data shows us that even if you have the same type of turbine from the same manufacturer, each turbine might perform differently because of the location. So that is why artificial intelligence is very important, because you can use individual algorithms for each turbine. So we can calculate the performance of individual algorithms based on more than 20 parameters. You can have individual power curves, and this is the baseline you can see here. Then in daily life you generate data. You can look at the data of the past 1 month. This is what you get in terms of images. And then you can see here the orange line, and that orange line shows the green energy curve. So in conclusion, I said that the underperformance was about 70%, and 7%, and you can see here. We don't want operators to do this manually, because the number of turbines might be too large, or the staff, the teams might be understaffed. It might take hours to look at it on the field. So we would like the machine to do this, and once it detects a significant gap, it can raise an alert. That is how it works. So when you look into details, we look at a few things. For instance, one of them is to see whether the turbine is located at the right direction. It could be because of a sensor error, for instance, as it is the case here. The turbine number 3 here, it is on the same ridge, but the angle is a little wrong. So we compare it with alert nodes. I put it simply for you, and we try to understand whether there is any loss because of the sectoral cutout. And on the left hand side at the bottom you can see the cutout losses, and we can conclude that turbine is getting the wind. That is not a problem, but because the angle is wrong, the turbine operates assuming that the degree is 40 degrees, for instance. So it also has an adverse impact on the production. So when you go into details, you can detect other problems. So the advantage is to have machine to conduct it, and then the final decision can be made by the people on the field. We would like the artificial intelligence to serve as an auxiliary intelligence. Like I said, there are a variety of parameters that we check, but that is the main concept. We detect problems and then we go into details. Other thing that we do is the predictive maintenance. I'm sure you have heard about it. This has been talked about very often. Why? Why do we need predictive maintenance, especially for the wind industry? It makes more sense. There is a study from the United States. They checked over 10,000 turbines. And they come up with this question. Like I said before, there might be some downtime which can be planned or which can be unplanned, They have this question: how much downtime do these turbines have because of a failure? When they are 3 years old, the turbines, 20% of the downtime is because of the failure. Maybe I can ask this question: what this percentage can be when they are 10 years old? How much of it can result from a failure because of a sudden failure, or when the wind peaks? Can you make a guess? Is it energy-based or time-based? Time-based. 60%? 60%? Can we give an award for the lady? Yeah, 75% is also close. Maybe we can give a placate of appreciation. Yeah, it's a serious problem. 65% is the real number, so it is very serious. And we have taken note of this. And, I'm not even talking about equipment replacement, which is very costly. So if I can estimate these failures beforehand, then I can save a lot of money. So this is why we have penetrated into this industry. You can do it on a vibration basis, but it is difficult to collect data. In that regard, we started with that. The concept is very simple. Let me put it very simply. The algorithms are very complicated, but I can tell you how it works. I can give you this example. Put it simply. We detect anomalies, abnormalities. We, monitor the performance of turbines based on the operation parameters and environmental factors. We check over 30 parameters. So we consider them, we take them into account, and we learn how that turbine works. So when there is a deviation, then we raise an alert. There are 3 main parameters that we check. There are many others, but X, Y, Z. We check them. We check them today in half an hour, in an hour, or every 10 minutes. T0, T1, T2. X equals 1, Y equals 2, Z equals 3. After a while, the machine learns it. It detects a relation. X plus Y equals Z. This is how this turbine works. But one day, X equals 1, Y equals 2, but Z equals 4. So this is an abnormality. So it gives you an alert. And the example you can see, the algorithms are very complicated, but by the end of the day, we need to provide end users with alerts. But of course, that is not enough, because they might not be satisfied with that. They wouldn't go up the turbine just because of a single alert. So when you go into details, you can see the plots. And it is complicated, but I can say this. You can see the performance of the target signal with the dark blue band, you can see actualization. But there is a range, a band range. It shows the normal operation range. Why is this important? Because on a normal case, it would be a straight line. We can tell this from the field and from the literature, from the customers, that until alert is raised, then it might be too late in some cases. So this is where machine learning comes into play. Based on 30 parameters, it can give you a band range. So before it hits the threshold, for instance, if the normal is 70 degrees, maybe when it is 0 degree outside, when it hits 30 degrees inside, then it can give you an alert to take measures. And you can also be provided with a cause, and you can know what to check, and it gives you a database with some recommendations. The main focus, the background might be complicated, but the main focus is to make sure that end users can easily understand it and take actions accordingly, and to provide them with examples. Let me talk about where we are going right now. We always talk about storage, data, prosumers, etc. Of course, they are very significant parts of our life, but AI will play a very important role because it is useful for production and consumption and price estimations as well. And it's also in most performance optimization. It could be for assets such as batteries or wind turbines. It gives you a maneuvering capability, and when you make right estimations, it is possible. It is not possible to do so without AI. It brings about new opportunities and new challenges as well. This will also bring about the issues of joint optimization of the fields. I usually conclude my speech with 3 messages. I like that. Artificial intelligence is now part of our life. It has arrived. It has been part of our life, and in our sector, it has created new values. It has proven that it can do so. It can turn potential energy into kinetic energy. We can see that. And you don't need to do something sophisticated, but you can start by collecting data and taking the very first steps of digitalization. So not doing anything is missing opportunities. So in your organizations, you should take the first steps if you haven't penetrated into this industry yet. But if you have, you can take further steps. That is my humble opinion. Thank you. Thank you, Bora Bey. We can have questions by the end of the session, but if there is anyone who would like to ask a question, we can have it as well. Back there is someone who raises a hand. Thank you for the information. My name is Recep Delivar. In terms of AI, can you make a comparison between Turkey and the rest of the world? How much is it used? And the second question is that you have mentioned this 65% loss when the turbines are 10 years old. It has 15 to 20 years of lifetime. So when you have an investment worth $100 million or $1 billion US dollars of production, how much loss can we expect? As a sector, I have been involved in this sector for over 20 years in different parts of this business, and I can safely say that, maybe this is something negative, but I can safely say that in terms of digitalization, we have been lagging behind when it comes to banking or gaming industry or e-trade. They are very much ahead of us. Even though banking industry is a conservative industry, it has made a great progress because their system was cumbersome. and it has expedited the digitalization. So we are lagging behind. I have had the chance to check the GT and other companies in Hamburg. We also analyze our competitors. Everyone claims to use artificial intelligence, but as you can imagine, it's like a crime not to engage in artificial intelligence. They put AI in front of everything. We jokingly say that we use real artificial intelligence. But what I see in Europe is that in terms of data collection and visualization, they are advanced. They have data analysis tools, but this is a very challenging step. I mean, the operationalization and automatization of the artificial intelligence is not easy. So there is a lot of opportunities in this regard. When I talk to companies who work on data analytic tools, they tell me that they would like to collaborate with us because visualization is one thing and advanced analytics production is another. Of course, there are manual reports developed by some European companies, 2 companies that I know, but they provide you with a monthly report by the end of the month based on the views of the data scientists. So how much efficiency would this provide for solar and wind power plants? I mean, when we use the AI, how much efficiency would we have, additional efficiency? Is it 25% or 50%? No, it's not 50%. Otherwise, I wouldn't be someone credible. But our analysis showed that from the literature, from our examples and clients, the analysis show, of course, this varies by the circumstances. This depends on how mature you are and how closely you monitor your fields. And if there are manual transactions that you can make, are you at 0 or are you at 10, for instance? So we estimate 3 to 10%. If you have 100 turbines, then you can have a chance to have 3 turbines for free. Thank you. You have made a great point, because this term, the AI is a term that is hollowed out. We maltreat this term in Turkey. We are capable in this regard as a country, unfortunately. It's like we don't even want to use this term anymore. Everyone use this AI-based system for everything. So it doesn't mean that you are really engaged in AI. So now I will give the floor from Algorithm Energy, Mr. Said, who does something similar. The floor is yours, Mr. Said.
Mr. Said. Thank you. How many of us are here engineers? Could you please raise your hand? Quite a few, right? Thank you. About this word AI, I have a little abhorrence for this word, I must confess. I live in the trenches, I live in the farms, and we are looking at problems as engineers as and when they happen. We have to be very careful between causality and correlation. As engineers, we are always looking for what is the reason, precise reason for this specific problem. What are the variables which are involved in that problem, and what can be done about them? If we let the genie of AI out of the bottle with its neural network and machine learning, maybe one day your software is telling you when there is rain and sunshine, your gearbox goes down. That may be a correlation, but this will have zero actionable value. So I'll approach this all from an engineering perspective. A lot of that has, by the way, been covered by Mr. Bora, and very well too. Thank you, Bora. So that saves a lot of time here. Now I'll start with the data, which Mr. Bora also started. And I'm going to request all of you, all the engineers, the people who work at the wind farms, please gather the data, own it. It's yours. These are your machines, you paid for them. No OEM, no O&M has any right to withhold your data. It's yours. Get it. And if you spend $5,000, you can get all the servers that you need. On the top right hand of the screen you see, and you can make your data center for each plant. If you want to throw some more money, you can bring all of that to your head offices. But the most important thing over here is, please, please, please get all the data. You may not know what you will need it for, but you will find out if you are focused and if you are resilient and if you keep trying yourself or by picking up guys like us. You will find out, because that's where the data is critical. And I think we've been following the Moore's law since last 50 years. Every 18 months, processing power should double, and every 18 months, the cost should be 50% of processing and storage. So it's never been cheaper to retrieve the data and to store the data and to own the data. Now let's move forward. Let's move forward to what we can do with it. And there is a lot that we can do with it. If living for 9 years on the plant has taught me something, I think I'm still a student, and so is my team. We are still learning. But to begin, I think there should be something very, very basic that you should do, and I'm still not going to use the word artificial intelligence here. Something very basic you should do. You ought to know, as a wind farm owner, what is the potential energy you must produce. And that is completely calculatable. There are standards out there. I'll refer to IEC 61400-12 and -12-1 and -12-2 series standards. Guys like us who have put their entire lives in the wind farms, they have written those standards. They provide all the mathematics that you would ever need to find out this answer, what my plant is supposed to produce every minute, every second, every hour, every day. What is my potential? Because that sets your benchmark. And this potential is not some theoretical value, it is a real value. Your turbines are getting real wind. Your turbine's power curve is supposed to be something guaranteed by the OEM. So he better stand up to his claims. Your turbine must produce that power. You've got to have that benchmark. So you ought to know what I should have produced today. And then you are measuring. Again, no AI here. You are just measuring from the meters installed on every turbine, installed on every MV switchgear room, installed on the main meters. Get the data from there. And that will tell you what did you actually produce. So now you have two values. What I was supposed to produce and what I have actually produced. And then this becomes this huge, years and years long quest of finding out why is there this difference? What are the precise reasons for this difference to arise? And this is, believe me, hard work, but not complicated work. It's really hard work. So let's get on there. Your turbine, a modern turbine, could possibly trip or stop for more than 800 reasons. You've got to catch every one of them. You have to find out exactly what time this turbine stopped, what time it started. Thank God we got our SCADAs with timestamp data, gigabytes and terabytes of it. Use that data of those timestamps, use the potential energy that you calculated, apply those timestamps, and you will find out how much you lost because of a specific incident. So in the screen in the bottom you see these little dots. You click on them, the whole issue comes in front of you. What happened, why this turbine stopped, and then you see the clusters which tell you that this is a problem which is happening again and again. And then there are these vertical lines which tell you this is something that happened all at the same time on all the turbines. So that's pretty revealing as an investigative tool. But more importantly, you ought to be able to calculate by these two simple things, IC standard 12-1 and 2, the potential energy, and the timestamps from your SCADA, and the meters, data from the meters. You ought to be able to calculate, even on an Excel, why you failed to produce what you were supposed to produce, and what exactly are those reasons. Like this plant has been doing terribly, you can see at the top. It lost about 13.5 giga, that's almost $1 million of energy. It's only a 50 megawatt plant. $1 million gone right in front of your eyes. And 2022 is even worse. So where is all this going? This has to be calculated precisely, which is what the pie chart shows to you. And that's simple mathematics, SCADA data, engineering approaches at work, telling you where you are. And that's why I'm calling it the basic performance monitoring class. What is your plant supposed to produce every minute, every day, every hour? What you actually produce? What is the difference? And what are the reasons for those differences? You can do it on Excel, you can do it on any software, but you've got to do it. Because once you do it, that's when you learn who your enemies are. What are the monsters that you need to go out and kill in order to improve your production and reduce your losses? But if you're not measuring this basic agenda, you're not going to go anywhere. And if you go for an AI at this stage, you will be full of doubt and correlations and not necessarily causalities, hard engineering causalities. I'll just skip quickly into some of the examples where I'll try to make them very, very understandable, very precise to my fellow engineers here. Okay, so here is a basic engineering causality. If some of you who are mechanical engineers would know that if you have dust accumulation on the blades, I'm showing a cross section on the bottom left-hand side. If you have dust accumulation, bugs, or pollen grain accumulation on the blade, please remember the tip is traveling at 300 kilometers per hour. That's a very fast speed. Try driving on a motorway at 140 and your windscreen will be full of bugs sticking to your windshield. So that's exactly what is happening to the blade. And because of this, the boundary layer on an airfoil shape will form earlier. The lift forces generated by the blade would be less. The aerodynamic torque generated by the shaft would be much less. And at the same wind speed, you will be producing less power. There's no genie in the bottle here, no magic trick here. Simple fact. Every aircraft that takes off gets its wings cleaned. Every aircraft that flies above 30,000 feet has a de-icing system on its wings so that it does not lose the lift. These are airfoil shapes. Our industry, borrowed this shape from the aviation industry. So, you're going to lose power. On the orange side, you see what happened. It was a rainy day. Let's be very happy. Blades are washed. You're all clean. You got a performance jumping up. It's been 4 weeks that it hasn't rained. You are down in the pits. You lost 10%. And there we are at the blue curve. Again, simple measurements. Let's complicate these measurements a little bit more, but not too much. Let's do it every day. And let's do this calculation, automate this calculation. Let's do that every day. Let's do that for every turbine, every day. And when you get this big, larger perspective over weeks and months that you see in the chart here, this is for a specific turbine, you're happy when you're washing or it rains, and you're unhappy, you're down by 10%, 12% when it's been weeks that it hasn't rained. Or you're in the middle of the spring and there's too much pollen flying around. Or you're close to the sea and the sea has got the salt and you're getting those deposits on the blade. So back to being an engineer, what do you do about it? If you want to wash, it takes 12 hours. O&M will give you a bill of $2,000 or $3,000 for washing a single turbine. And what about those 12 hours when the turbine will be down? You'll not be producing any power anyways. So you've got to do it quickly, you've got to do it cheaply. So we worked for about 5 years in developing this technology. This is artificial rain, an artificial rainmaker. It's mobile, you can carry it in front of the turbine, you throw objects 100 meters high, you create artificial rain. It's none of O&M's business, whether he stops you or not, none of OEM's business. You've got a high pressure jet, laminar flow nozzle, which you see in the picture. It looks like still water, but it's traveling at 70 meters per second. And the trick is to make it laminar, so it can go higher. And you can create this artificial rain, upwind of the turbine, be done in 10 minutes, the blades will be washed, and the turbine will think that it had rain. And she'll be happy, you'll be back on 100%. That's one very simple but hard work which engineers must do, focused work to get the results and be able to validate them. By the way, we've got this validated from TÜV Nord independently as well. So this is in commercial operations already. Okay, here is another, this may not scare you, I hope it doesn't. It's just telling you a simple thing. Turbine number 70 is going to go down. That's what it is telling you. It's sending you out emails that this turbine will shut down. For which causes? So here we draw a mathematical tool. We call it KNN algorithm. You can Google it. It's out there. So KNN is basically just a fancy word for trying to find out what are the closest neighbors. If you've got a data set, you want to compare it with millions of other data sets, and you want to find out very quickly which one of my data set it's very close to. So that's your KNN. So what this KNN is doing, and back to engineering, you've got several heat exchangers in the turbines. So you've got one for the gearbox oil cooler, that's a heat exchanger. You blow air on a heat exchanger, the oil flows through it and it cools down the oil. You've got another heat exchanger in the IGBT cabinets where you have your coolant which cools the IGBT cards, and the turbine feels happy. And then you've got your generator cooler, another heat exchanger. You blow the air through the generator coolers, and that keeps the windings and that keeps the bearing, non-drive-in, drive-in bearings happy. If you don't do that, the turbine shuts down. And it always shuts down when it's the high wind. Well, that's when the temperatures, they shoot up. So you take this KNN and you teach him supervised learning, not causality, correlation mixed up and all. You teach this data set, supervised training, that when I clean my heat exchangers in the last maintenance, what did the data set look like? Data set of what? The oil temperature, the ambient temperature, the power that you were producing at that time. So what did the heat exchanger data look like when I cleaned the turbine? So that's one of your neighbors. And then there is another extreme neighbor, which is when my turbine tripped because of high oil temperature or high generator temperature or high IGBT temperatures. What was the data set like at that time? And when you have data from 5-10 years, those terabytes that Mr. Bora talked about, it's easy to figure out where are the neighbors. And when you have the fences of what's the best and what's the worst, you can start teaching this algorithm the shades of the colors that you see over here. Darker, bad. Greener, very good. And then when it happens again and again, soon you're able to fine tune it to perfection. It'll tell you about 3 weeks earlier when do you need to clean those things. Regardless of what your O&M tells you to, you would know. You get a message in your email, you get a daily action log in your daily reports and all, and you would do something. So that's one approach of KNN, trying to figure out the downtimes. By the way, in my country, it saves about 0.4% of annual production, this family of algorithms. I'll quickly move to one or two more.
Just can you remind me time?
I'm sorry. I'll just finish this and then I'll just move on.
Sure.
Okay, here is another approach. This is another family of algorithm, which is the differential algorithm, which is about what is the rate of change of the value of the sensor. So here we are looking at hydraulic brake. The red line is dipping normally, and the blue line is dipping very fast. And it means that the accumulator pressure of nitrogen gas is very low. So you're not able to store hydraulic pressure for long. And you better fix it quickly, otherwise this can be dangerous for pitching, this can be dangerous for your secondary hydraulic brakes or your yaw brakes. I'll stop here. I can go on for many more such algorithms. The hope and the message I want to convey is, please don't be terrified. Own your data. Get it at all costs. Give it your best shot to get the basic information right, and then focus for many years to solve problems one by one. Thank you very much.
Thank you very much. We will have questions in the Q&A session. Now we will proceed to the next speaker. You have mentioned the estimation aspect of AI. I would like to give the floor to Güven Bey. My name is Güven Fidan. Is anyone following us on LinkedIn? Is there anyone? We try to produce different types of content for the renewable energy industry. We do this by using weather forecast data. We would like to raise awareness, and we would like to make sure that our capability is well positioned in this sector. As you know, there are many different types of weather forecast companies, especially around the world. So we would like to be an alternative at the local scale. So in addition, we also would like to use our know-how, use this know-how, as the title of this session indicates. We would like to use it in terms of AI and data analytics. So I would like to tell you about how we use it. We are a consultancy company. We also provide advanced level services for high rises. We calculate their facade load, and we also model weather conditions, and we also provide designing team with services. We can provide them with information about how many days they would have discomfort because of the wind, and we use fluid dynamics. It gives us a great deal of opportunity, and since 2014 we have been using this data, but we used to outsource it. We paid for this at the time. And then, just as we model a flow inside a room, we also model weather conditions at the atmospheric scale. We can, as you know, the ICMWF is running models in Europe and in the United States. So it provides us weather forecasts, and most of them are publicly available, but their resolution is very poor. So we would like to make sure that their resolution is high, is improved, and we would like to also achieve consistency in other words. This is actually in parallel to AI. It is more comprehensive. It is more theoretical and numerical version of AI. So this is a process, and in this process, the amount of data is huge. It depends on cases that you resolve. Of course, when it comes to an atmospheric condition, then as Bora said, the size of the data grows a lot, and when you visualize it, you need different types of tools that you need to develop, and based on our needs, we have integrated it with building physics, and we also calculate what direction the wind blows, and we rely on performance analysis. So in this case, the building discharges the polluted air from the clean outlets, and then with the reverse pressure of the wind, we provide the users with solutions at the design phase. When it comes to wind power plants, we are interested in them from the perspective of insurance. As you know, natural disasters are included as a part of fire, and we also work on fire simulation projects with insurance companies, and we would like to make use of our weather forecast data capability, and when we tell them about this, they tell us if we have any data about thunderstorms, for instance. That is why we turned this into a project, and then we published a paper in Europe. We came up with this Thunderbolt projection algorithm, and thanks to this algorithm, we took a retrospective look at the past 10 years in Turkey with 3 kilometers of resolution. We have made use of computational fluid dynamics. It has activated 6,000 cores as a part of a system, so we came up with a risk map based on the severity and the frequency of the thunderbolts. And when we talk to insurance companies, they validate this data. They came up with strategies depending on where thunderbolts are happening at certain locations across Turkey. We see severe types of thunderbolts, and it causes some accidents. So when they drove up insurance policies, the insurance companies make use of this data that we produce when they have strategies laid out for their companies. This is not the only element for decisions, but it is an instrument for making decisions. But in any adverse case, we can use this data for reassurance and to make the payments, to help them make the payments. It makes things easier for them. And this is not just about Thunderbolt. There are 10 different types of risk data sets. This includes Thunderbolt. It also includes, storm, hail, snowfall, rainfall, fog, or agricultural frost as well. Then we came up with a flood risk map with 25 meters of resolution, and then also we have generated data for landslides and forest fires. So this is updated every year based on satellite data on a yearly basis. And the risk projection algorithms, we asked about this to our partners if they have this need or not. And based on radar images, we place them within a certain radius. The field officers get an alert when there is something wrong. So our goal is to provide projections 3 days before they happen, before these things happen. And we provide this service, and in cooperation with TUREP, we published an article, a paper, as a part of a data analysis. As I said before, we also have checked the last 12 years trends in thunderbolts, if there is any increase or decrease. So that is how we have come up with some conclusions. These are project-based works, but we also have a workability product, a product called Workability. Now we can provide weather condition forecasts by hourly rates So as Bora Bey said, AI has many aspects. So when you have an AI-based product, it requires a great deal of effort. It requires a great deal of effort on the field, and you need to provide reliable data and consistent data, and you also need to scale it. And this is where ML engineering comes into play, and this is a new area. When you have the system, I can personally follow this from Tesla. So ML engineering is being part of our lives more and more. So we partially do it for wind estimation.
Böyle bir platform şu an public, herkes açık, bütün sektör buraya girip bakabiliyor ve bu geri bildirimlere göre şekilleniyor, sürekli revize ediyoruz. Her gün yarın hava durumuna göre restlerin sıralamasını veriyoruz. Bu yarınki hava durumuna göre Türkiye'deki belli başlı restlerin türev veri kaydına göre sıralanmış. Rüzgar potansiyellerine göre kimin resti yarın önde olacak diye dikkat çekmek amaçlı. Soranlar oluyor, ya bizim saat geride kalıyor, bilerek mi yapıyorsunuz diye. Öyle bir şey yapmıyoruz. Diğer konu orman yangınları ile ilgili. Şimdi biz multidisiplin bir firmayız esasında. Dediğim gibi ileri seviye mühendislik hizmeti verdiğimiz için çok farklı branşlar, arkadaşlar var. Meteoroloji mühendisi, biyometrik mühendisi, yazılımdan zaten destek veren arkadaşlarımız var. İşte ML operasyonları için farklı arkadaşlar bünyeye dahil oldu. Makine mühendisi arkadaşlarımız var, fizik kökenli arkadaşlarımız var ekipte. Burada aslında farklı hibritlemeleri yapmaya yönelik de niyetlerimiz var. Hatta bugün başka bir kullanıcımız için onun sözünü de aldık. Orman arazilerini dijitalleştirmek.
We haven't focused on production capability, production projection. This platform is public, everyone can check it. And based on feedback, it is revised on a constant basis. So depending on the tomorrow's weather condition, we can rank the wind power plants in Turkey based on the TUREP database. You can see the wind potential and you can see their rankings here. We would like to raise awareness about this. Some people ask us whether their time lags behind, whether we do it on purpose or not. Of course not. Another important topic is the forest fires, the wildfires. We are a multidisciplinary company. We are joined by many different people with expertise in meteorology, in software engineering, ML operations, and machine engineering as well, people with background in physics. So we have different hybrid plans and projects today for one of our users. We have had a commitment from that user. We digitalized forest lands. There are some data, but with regards to forest risks, fire risks, we can also provide thresholds for certain temperature and certain humidity, and it also provides you with data about forest coverage, data for tree types and species, and you can classify them based on how risky they are, and you can digitalize all these land information and you can turn them into spatial alerts. And we do this with regards to a wind power plant. We also have a dialogue with TEİAŞ. This has been brought up in terms of the private distribution lines, transmission lines. So thus far I have talked to you about a package service. There are users for this already, but our goal is to focus on the technological aspect to raise the bar. Our main goal is the parametric insurance. When it comes to lack of wind and lack of wind, there are parameters like this. we also would like to get involved in smart contracts. Blockchain has laid out a significant infrastructure for that, but when it comes to projections which are being improved, we have some devices for Thunderbolt projections. So in the midterm and in the long term, we would like to serve as a third company between financial institutions and the investors. That is what we would like to achieve. And we have determined some thresholds. You can come to an agreement about some threshold values, but when there is no wind on a given day, then that loss should be compensated by an insurance company as a part of a business model. So these can be part of smart contracts, which is the case right now. So we work on this, we work on the infrastructure of this. So we are working on that. And in addition to facilities, when you have a broader perspective, we can also provide services for agricultural businesses, for drought or for flood. We can also provide commercial companies with the same type of service. That is the end of my presentation. Thank you. Thank you. Now I will give the floor to our final speaker, Ercan. He is involved in one of the major aspects of AI. First of all, thank you for joining us in such an energetic congress. I am proud to be here in front of you as an entrepreneur. And I would like to thank you for your patience and staying with us so late. So, DroneCare is an industrial drone services company. So, when you consider the fact that we are called an industrial drone services, then we receive many phone calls. Because people think that, drones can solve everything, can solve every problem. And we have received many applications. And the first thing we do is to tell them that drones cannot be a solution for everything. And even if it is a solution for some cases, your investment may not provide you with some advantages or profitability by the end of the day. But when it comes to wind turbines, things are very interesting because when you make comparison with the global drone projects, it is probably one of the most effective projects, the drone projects. Projects that provide services for wind turbines because you can make concrete comparisons. For the first time, I came across with wind turbines in 2006. I used to be a paraglider. I have some students of mine here from the paragliding courses. And I went to Granada, Spain, for paragliding. And for the first time, I saw a wind turbine there. And it was 2006. And I had my friend Fikret. And Fikret was involved in blade audit, blade checks as well. So we were talking with him, we were talking about how difficult it is. So I was amazed by the size of the blades there because it's too big, really big. And Fikret said that it is so big that we can complete our checks in one day. So then I thought to myself, why don't we use drones? And I have asked this question to companies for 10 years. Why don't you use drones? Finally, in 2016, I convinced a Norwegian company, these services are now being provided around the world, so let's try it. And Nordex has done so. Ferit is a very visionary figure. And he agreed, and so we did our first trial. And it was a very successful trial. And then, all around the world, drone-based checks have become popular, Fikret had to quit his job, but all the wind turbine operators have seen how beneficial it is. Let me ask a question at this point. Where are wind turbines? Where are they located? They are located where the wind blows strong, and they have to work 24/7 unless there is a major problem. And as you know, they are located at very difficult logistic sites. They have very challenging production plants. So they work 24 hours, but they face many problems. This may include mounting problems, installation problems. You may not see it from the surface, but you can notice them when they are operated. And there are also structural damages. Thunderbolts can cause damage as well. And in some cases, village people can have a shooting trial or a drill shooting at them. So these damages, installation damages, they may be rare, but these blades can rotate for up to 200 kilometers per hour. So this causes major problems if you ignore them. It can lead to some serious problems. At this point, let me ask another question. Have you ever heard about inside leg law? It's very simple, actually, by definition. If you ignore something, then it can cause exponential consequences. The best metaphor to give is the toothache. If you have a toothache and if you don't go to a dentist, then your tooth can be pulled out, removed. That's the same for wind turbines. Small damages can lead to major damages, major problems, and you can lose blades in some cases. One day you may wake up, you think that they are robust and they are not. What would you feel? So that's the same feeling experienced by wind turbine operators. Since 2006, we have been, conducting inspections. There are many horrific pictures, but because of the NDA, we cannot publish them here. I cannot share them with you here. But this photograph makes the same impact. Really, a turbine operator, when he wakes up in the morning, when all the blades are down, then you can imagine what he feels. Despite these risks, why do operators conduct supervision or checks less frequently? We don't have an exact answer for this question, but the underlying reason is the efficiency concerns. Because of the efficiency concerns, they do not want to stop the turbines. They want to stop the turbines when the wind blows the least. So it takes 60 days in Turkey, so you have to have all the checks and controls in 60 days, but you are also joined by damage supervisors, blade repairers, the tower operators, elevator people. So all these operations have to go on at the same time. So it is not easy to manage this operation on site. In most cases, because of the lack of organization, we can see that checks are problematic. So this is a chronic problem when it comes to wind power plants. How about the blade damage checks? Before the technology was introduced, a team of 3 persons would go up to the turbine and they would, identify the problems. When they face a problem, they would take a photo, they would take notes, and then they would go back to the turbine and the other blade would be down, so they would check it as well, and it would take an entire day. And by the end of the day, this 3-person team, this ROPEX team, could complete these procedures in 1 day, for just one turbine. So all day the turbine would have to stop. Imagine you have 50 turbines, then you have to have checks for 50 days. You have to have a report for that. You have to deliver it to a client, so it's a serious problem. That is why companies conduct checks every 2 years. So this leads to major problems. And in fact, one of the wind turbine operators told me this was years ago, that he said that, they would conduct checks every 6 to 7 years. I mean, the checks on blades, so they are left alone. So because of this lack of checks, minor problems lead to major problems. In some cases, blades get broken by the end of the day, and it causes inefficiency. And in fact, we use drones not only for wind turbines, but also storehouses. There are operations involving people. These checks need to be strict, and we face similar problems. In order for these checks to be reliable, operators make a lot of effort, and because of their efforts, your performance never increases, it never improves. You cannot tell the operator, to climb faster this 6.5 meters long tower, or you cannot climb faster this 50-meter long tower or blade. So you cannot improve the performance. It is something that you cannot improve. And because of some manual procedures, it also creates some distraction at that height, and it causes distraction, and it requires a great deal of workforce as well. It can cause us accidents if you're not careful, and it also increases the cost. So these are the general problems for such operations. So what kind of solutions do we offer? Thanks to our solutions, at risky locations in terms of occupational safety, we can work with fewer staff members, and we can improve the efficiency by 8 times. And with ERP integration, we can also provide reports on an instant basis. Now the wind turbines are checked by drones everywhere around the world. It is very popular now. There are 2 types of checks. One of them autonomous, and the other one is manual. In both cases, an operator, places the drone, and the drone takes off. And then when the blades are checked, their photographs are taken, and per turbine it takes 400 photos. Then after that it proceeds to the next turbine, and it takes 50 to 60 minutes per turbine. And in one day we can complete the checks for 20 turbines, which is incredible, because back in the day it would take 3 persons to complete the checks of 1 turbine. I mean, it would take 1 day. Now you can do the same for 20 turbines in a day. And we also use virtual glasses, which help us to take instant actions, especially for problems regarding class 3 and class 4 turbines, and you can notify the clients accordingly. And we have prevented many major potential accidents from happening. And after the photos are taken, we also use real AI, so to speak. There are 2 types of AI. The first one is the one that we have been using right now. It is the baby steps that we have been taking because we have 1.9 million data sets yet. And after we have 1 million data sets, we can tell whether the blade is clean or not. We can tell the difference. But those who are not clean are separated, are picked out. And this gives us some time, this gives our reporting team time. And when we reach 10 million data sets, then the machine learning will help us in terms of damage diversification. And you can see these photos. They are tagged by our reporting team. And the sensors on the drones can also calculate the distance between the line and the blades. And it can also calculate the size of the damage, the extent of the damage, and it can give you data about that. After this, the reporting team delivers it to clients in a PDF format. But, at the time of Ropoxes, the reports were delivered in a PDF format, but we raised an objection to this because our biggest advantage is the visual data. We can make good use of visual data, but for ROPEX operators it is advantage. Our biggest disadvantage compared to them is the fact that we cannot touch the damage. We do not contact the damage physically, but ROPEX operators can go up and can contact it. They can feel it, but we have reports based on estimation. So when you put it into a PDF format, then it doesn't make sense. We have altered the format. This can be sent by email. So once you click on the PDF file, the original image can be enlarged and you can see all the details. And here you can see how a laser sensor calculates the distance and the extent of the damage here. So this is an advantage. This also gives an advantage to the repair team to see the extent of the damage or to estimate the extent of the damage. This also brings about field management or spatial management, because you can create database based on GPS coordinates, and you can make comparisons to situations 6 months ago or 1 year ago, and you can see whether the damage grows or not, or you can rank them in class 3 or class 4, and you can download all of them. And it gives you some action plans to take. If there is an alert about any of them, then you can see whether they are fulfilled or not. So this gives you an advantage in terms of field management. And we have problems. Of course, we have a great deal of problems at this stage. The main problem is the planning. We only can make plans when there is no wind. And our schedule sometimes conflicts with the schedule of subcontractors. In terms of staff members, we need to work with experienced subcontractors, and we need to work with experienced operators to run the system. And this also increases the cost per unit. And there are also transportation expenses for this team. And there are some chronic problems, including calibration. Once you run the drones, you have to calibrate them. We said that it takes only 1 hour to complete the checks, but sometimes calibration takes a lot of time. And anti-drones are very popular right now, especially in Turkey. We were in Hamburg for a fair. I asked people, they don't know about it, but in Turkey, everywhere, they have this Intel system. All the security forces place this system all around the country. So drones take off, but it goes to Ankara, for instance, all of a sudden. So you have to remove it from the autonomous drive, and you need to take control back, and you have to have it land. Otherwise, it would go away, and you couldn't find it anyway. So there are interactions about them. We need to eliminate these problems. And in general, we have this problem that we cannot monitor where Thunderbolt hits. and because of the lack of monitoring for potential damages, it becomes a huge problem. And in future projects, this problem will be eliminated, hopefully, and I hope that I will be able to have the chance to be here again, and I will tell you that we have succeeded, and I will give you the details about our projects. We have a very good team, as I said before. They have long years of experience in aviation industry and especially in industrial solutions. They offer very good solutions. So I would like to thank you for staying with us until this time. Thank you for your attention. Thank you, John. Is there any question for our panelists? I think there is none. Then I would like to thank our panelists and our participants for staying with us, and I hope that it has been efficient for all of us. Thank you.
Where like